Hello, this is Colin Lobo, Executive Vice President of Engineering with the National Ready Mix Concrete Association. This presentation outlines some basic quality control concepts for ready mix producers and resources that would be available from NRMCA for producers. It is supported by the Small Producer Council of the NRMCA Membership Committee, and while the intent is to provide some general information for smaller ready mix producers, these concepts may provide ideas to larger established concrete producers also. The basic premise here is that quality control should be considered as an important activity for ready mix producers and requires some investment in time and personnel. It is an important factor, besides good service to your customers, that obtains and retains your customers. Concrete supplied should comply with the purchase order, that's the basic premise, the project specifications, and in many cases, the customer needs. Concrete supplied should also be consistent from load to load. Quality control activities can help identify reducing the producer's costs and maximizing profitability, so it can be justified expense. Ideally, quality control activities should be proactive in the sense that you should ensure that concrete that is delivered meets the customer's requirements and any defective concrete is identified before it is placed. The time spent in troubleshooting problems after placement should not be considered a quality control activity and time spent should be minimized. It is often said that the responsibility for quality involves all personnel in a ready-mix concrete company. That includes the front office, purchasing, sales, operations, regulatory compliance, order takers and dispatchers, plant operators, and the technical service personnel. They all play an important part to delivering a quality product, and their responsibilities should be clearly identified. It is understood that in a small company, there may be personnel who perform many of these activities individually. So let's get started with the presentation. Some of the NRMCA resources that are available are outlined in this link, and we will go through some of these resources during this presentation. The NRMCA works through a technical committee referred to as the Research Engineering and Standards Committee. This committee has developed this quality control guide for ready-mix concrete producers. That's a good resource that outlines the basic essential items that should be in a concrete producer's quality control program. The quality management system is a more comprehensive document that can be developed slowly by a ready-mix producer, but it goes through several aspects of quality and tries to assign responsibilities to different personnel within the company. We will discuss some of these other resources as we go along. These are some formal definitions of basically what we call quality control and quality assurance. In general, quality control are activities done by a producer to ensure that the concrete meets the requirements of the project, both for fresh concrete as needed by the contractor and for hardened concrete in the structure as needed by the designer of the structure. In this concept, the focus should not only be on achieving strength requirements, even though that is the primary basis used for acceptance of concrete. Quality assurance, on the other side, is the general activities done by the purchaser or the owner to ensure that the concrete supplied to a project complies with the purchase order or the specification. In some cases, quality assurance also is the documentation internally done by the quality control processes to document to management that the company is achieving its quality goals. So that's the general difference between quality control and quality assurance. These are some of the factors that influence the concrete quality. We need to make sure that we are selecting the right materials from the right supplier and that we have some control on the variability of the materials that we use in concrete. We should not select suppliers only for cost. We should also select them based on the quality that they supply and the support that they provide to manage their materials. Concrete producers have to develop mixtures for a wide range of applications from low strength, high durability. We need to establish mixtures that meet the different requirements for different applications. We also look at the point of developing mixtures to minimize cost and to achieve the required performance. Production processes involve checking or making sure that the scales and the other devices for measuring materials are accurate, that when we batch concrete, we are batching materials accurately. This is important both for inventory control and for the performance of the product, as well as the cost to the ready-mix producer. That also involves maintenance of different components of production and the operational activities such as working stockpiles, etc., during the production process. There are several other conditions that have to be considered by a ready-mix producer in terms of temperature, ambient temperature, seasonal variations in temperature, distance to the job site and maintaining slump and without adding too much water. Placement and consolidation methods might have some impact on how we proportion mixtures. You may have to do different things for pumping concrete, for flat slab trowel surfaces, etc. And then eventually we have to look at curing and protection of the structure during the construction process. So some general goals. This is a statement given by a concrete producer at one of our sessions. It says that if you have an effective QC program, you simply won't have as many problems. And in having an effective QC program creates more time than it takes to implement that program. So that's a basic premise that you should consider. So in general goals for quality control, do you know what you're putting in your concrete? In terms of, do you know the characteristics of the materials that you are using? And do you know how much you are putting into each batch, whether you're being accurate in your batching process? After you make your concrete, do you know how it performs in terms of slump retention, air content, temperature, slump retention over time, and then eventually things like yield, strength, and any other durability properties that are needed? When you batch different loads of concrete to the same customer, are you consistent between loads? This is very important for some applications, especially for slab construction, where you cannot have much variation between loads, especially on set time, bleed rate, and those sorts of aspects that impact the finishability of that type of concrete. In general, you should consider that it's more effective to avoid delivering bad concrete than to troubleshoot that problem after it's delivered. It also is more expensive to troubleshoot the problem after it's in place. The other types of decisions management needs to understand are to identify what factors that you can manage to minimize variable concrete. There are so many sources of variation that impact the variability of concrete, and you cannot address all of them. So pick some factors that you can reasonably manage to minimize the variability of concrete, because minimizing the variability of concrete minimizes your costs and supports customer satisfaction. The other factors, as when you develop your mix, what factors can you choose to minimize the cost of your mixtures? So we will have, in general, these are the types of scope of quality control activities: sampling and testing of your materials, and then when you make your concrete, testing the concrete, control of the production process, procurement of resources that will improve your quality. How do you optimize mixtures? Do you have to use 800 pounds of cement for 3,000 psi concrete? Or can you reduce that? Naturally, cement represents your highest cost in your concrete mixture. When you get orders and specifications, is there a review process to make sure that everything that is needed in that order or specification is understood before concrete is developed and delivered? Do you have a process for field control? And some of this may be more for higher specification type work in terms of developing new types of mixtures for different types of applications, etc. So this is generally the scope. Let's take a little look at the general cost. This is developed from the NRMCA annual performance benchmarking survey. So NRMCA annually facilitates this survey and publishes a report. This is a financial survey, but it's also useful to understand where your costs are and how your profit margin can be impacted. So this chart compares average costs of a typical member who participated in the survey, the average selling price, how much does the materials cost, how much does delivery cost, what are the plant costs, what are the fixed front office costs, and what is the average profit. This is also compared to the more profitable producers, the upper 25 percentile or percentage of the profitable producers. How does that compare in terms of their profit margins being higher? How are they varying their cost structure and to the lower profitable producers? So you can see that there's a difference in sale price and there are some differences in their costs. The point here also is that materials represent 50 to 60% of the cost of percent of your sale price. So that is a big portion of the pie that if you can reduce your material costs, you can improve your profitability. You also have other personnel in your company that impact your cost, and all should be aware of how they can impact their cost and reduce their cost to improve profitability. So take a look at this performance benchmarking survey. Within each category, there are several line items that are also there so that you can get some ideas as to how do you monitor costs and establish pricing for your concrete. NRMCA also has on its website at the quality section a tool that was developed by a developing industry leader group as to how you might quantify the cost of poor quality. This spreadsheet can be used internally by a company to identify the dollars per cubic yard related to the materials. If you get bad materials, what the impact is. What is the impact of batching or other issues at the plant? What happens at the job site and other internal costs? And eventually you will get a dollar per cubic yard related to the quality or cost of poor quality, and the intent is to minimize that cost. And sometimes it may need an investment in resources or people to reduce that cost of poor quality. So take a look at that, see if that can help you in your journey to quality. Ready mix concrete is a people business, so you need to have proficient and qualified people to do the necessary jobs to ensure quality. We recommend that you develop clear job descriptions as to the different functions that you want to hire people for, and then try to hire people consistent with those defined job descriptions. There needs to be some internal training. All people that you hire may not be familiar with our industry, and you may have different resources available from NRMCA or internally, or with your suppliers that can provide the necessary training to your hires or new hires. In some cases, you may have to consider contractor education so that they handle your product properly and put it in place properly in place. These are the various job functions that may need some training programs. NRMCA has developed training programs as well as certification programs for various of these job functions. So take a look at this section of the NRMCA website that can give you an idea of some of the internal training programs as well as online offerings that can be used on demand. NRMCA also has a one-day pretty comprehensive course on improving concrete quality. This course can help you establish some quality goals that you can then monitor that make sure that you're achieving. Processes for monitoring the variability of various materials, the impact of batching accuracy, the importance of controlling water added to the concrete mix, impact of delivery time and temperature, how does testing affect your concrete mixture quality, and then developing a quality plan and periodically auditing that to make sure that that quality plan is being followed. We have the issue of selecting the right materials. This selection of a supplier should be based on quality and uniformity of the product that they supply and the service and support, not necessarily only on cost. Suppliers, collect your material supplier certification, keep those on file periodically, look at items on that certification to verify that these things are not changing a lot because they have an impact on your concrete quality. You might choose to do periodic testing of these materials or ask for information from the suppliers about their uniformity from their source. The charts on the right, the one on the top is a variation of cement as being supplied from a cement supplier. And as you can see, the cement strength does vary with time, and that variation can cause a variation in the concrete strengths. The chart on the bottom evaluates the uniformity of the grading of an aggregate source over time, and you can see how that varies with time. Naturally, a significant variation of the aggregate grading can impact whether that mix comes together well. So take a look at these types of resources that you might need to track in terms of monitoring the quality of your suppliers, of the materials that you're using. You then develop mixtures. The process of developing a mixtures can be an ACI process where you develop a 3-point curve varying the water cement ratio or the cement content, and then establishing these relationships for different types of mixtures that can include fly ash, can include air entrainment, and understand the impact of air entrainment. Whenever someone says, I want a 4,000 PSI mix, you naturally have to over-design that in accordance with ACI to develop a mix that has a higher strength so that you have a low chance of having test results that will fail the strength acceptance criteria. Many producers evaluate cement efficiency and PSI per pound. Take a look at that, see how much strength you're getting per pound of cement you use in your concrete mixtures. Understand that every 1% of air that you add to your concrete reduces your strength by 5%, so try to get an idea of the impact of entrained air on the performance of your concrete. Eventually, what you want to do is to optimize and minimize the cementitious material content and minimize the amount of over-design that you produce for a specific type of project. You have to develop submittals for projects that have specifications also. So this is an important factor, a part of developing mixtures for different applications. Specifications and orders can vary, and it's important that the person receiving the order understands the details of what's required for the concrete. That could be the salesperson or the dispatcher. Identify all the requirements in the orders and specifications, whether there is not only a strength requirement, but whether there are other requirements such as a maximum water cement ratio, a minimum cement content, any limitations on the materials that you can use in your mixture. Obtain a copy of your specification to ensure that you know all those details. Also make sure that the specification is achievable. Make sure that the requirements are consistent in terms of the slump requirement, the air content requirements, and if there are problems, make sure that there's a communication through the contractor to the designer to correct something that may not be achievable. In many cases, you have to develop mixes and strength test results by a 3-point curve process. You may have to develop test data for some additional tests such as shrinkage, durability type testing, alkaline aggregate reaction. You might have these resources in-house. Generally, you might have a strength testing machine, but often you may have to use a third-party consulting lab for these services. Make sure that you choose a lab that is proficient, that can give you the right support, and that is qualified to perform this testing that you will use for the data needed for submittals. At this point, we have covered several basic aspects of quality control. We will now go into some other of the operational aspects related to managing quality. So we'll talk a little bit about some of these operational issues. Accuracy of measuring devices. We should ensure that scales are determined to be accurate. These are the requirements in ASTM. as well as the NRMCA plant certification program. So periodically you have to call in a scale company that brings in a certain number of standardized test weights and puts them on your scale along with product loading to verify that your scales are accurate and through the range of use that you anticipate. And you also need to check that your water meters are accurate. This often requires that you dispense a certain quantity of water into a drum and hang it on a scale to verify that you're accurate. Admixture companies generally check the accuracy periodically of admixture dispensers. So these are requirements in the standard. It is very important that you verify that scales are accurate because if you are not batching materials accurately, you will have inventory problems, you will have cost issues, and you will have impact to the quality and variability of the concrete that you produce. Managing materials, you should make sure that besides the standard specifications for aggregates handling and stockpiling, you need to make sure that you maintain a clear separation of all the materials in terms of cementitious material. Make sure that the pipes are properly labeled so the right material goes into the right bins and silos. That aggregates are stored so that there's no cross-contamination between different types and that the loader operator is working those stockpiles to minimize breakage and segregation of the aggregate products. You need to make sure that the bins and silos and weigh batchers are properly maintained so that the gates close and discharge material to the required accuracy when batching materials. Aggregate stockpiles, of course, when working an aggregate stockpile, the loader operator has a very important impact on the quality of concrete. Minimize segregation so that you have a large face of the stockpile, that the aggregate is being loaded into the plant so that they have a minimized impact on segregation of the aggregate and relatively uniform moisture is being fed into the plant system. When you look at shipments, you need to identify that if you ordered a number 57 aggregate, you didn't get a number 89 stone. Make sure that there is a visual check on the material that you have received and make sure that when you receive cementitious material that you have identified with the bill of lading that the material is the correct one and that you give the operator the correct information regarding where to load that material. The other aspects of making sure that make sure that unloading, stockpiling, moving of aggregates are without impacting segregation, that you have separate silos for cementitious materials or at least dual wall separations if you're using a single silo for cementitious material. Admixtures are protected from freezing and cross-contamination and that the aggregate sizes are stored properly to avoid cross-contamination between different types. Aggregates are stored in separate bins, etc. Condition of production equipment needs periodic maintenance. Make sure that there's maintenance of the batch plant equipment, the truck mixer conditions in terms of wear and buildup of the mixers, that you're following a maintenance schedule, as well as a replacement schedule on mixer drums and other systems. The transfer systems for materials, especially liquids, in terms of piping, so that they are not impacting the accuracy of the materials that is being batched. NRMCA manages a plant and truck certification program that verifies and checks on various aspects of your quality system as it relates to the production process. So if you are required, you might be aware of these processes, but it looks at the storage of materials, it looks at the accuracy of scales, it looks at the batching accuracy, it looks at your ticketing system, it looks at your central mix system, and it looks at the condition of your truck mixers. And also look at selection and investment of new equipment and processes that can improve your quality. One of the biggest challenges in ready-mix concrete production is to ensure that we have uniform water content and the water content in the mixture is consistent. We can batch other materials relatively accurately, but sources of water can be incorrect. So periodically, at least daily, you should measure the moisture content on your aggregates and make appropriate adjustments to mixture proportions based on aggregates. If you look at that sand stockpile, you will notice that the bottom of the stockpile is very wet relative to the top. So as the loader works on that stockpile, make sure that there is a uniform process by which he feeds the plant. Batch adjustments are necessary when you know what your moisture content is. Don't assume that it's always the same percentage. And then if you use moisture probes, you have to periodically calibrate those moisture probes with a cook-off on the aggregate so that you're making sure that the aggregate moisture probes are giving you the right numbers and making the right adjustments in the batching process. These are the requirements for accuracy. Now, naturally, when you're batching concrete, it impacts not only the quality of the concrete, the yield of the concrete, but it also impacts your inventory and cost. So periodically look at your batch records, make sure that when you have a target weight of cementitious material or aggregates that you are batching within the plus or minus 1% required by the standards, that your water batched is within plus or minus 1.5% of the target quantity. And when you start getting into problems with excessive batching, of course, then you're giving away materials for free. It also impacts how your concrete mixtures will perform and changes the variability of your product that will impact future work. So these are generally the batching accuracy. A lot of companies primarily look at the batching accuracy of cement because that impacts their cost, but that's an important initial step to look at when you check your batching accuracy. Another important factor related to the quality of produced concrete, especially when batching into truck mixers, is to have a proper batching sequence so that concrete can be uniformly mixed within about 100 revolutions at mixing speed. And this is a recommended batching sequence to ensure that you don't get cement balls in the mixed concrete. So make sure that you don't add any fine materials as the first material introduced into a mixer because that will not break up from the head of the drum. Try to get some coarse aggregate with almost 3/4 of the water in first and ribbon the aggregate in cement and then end with the cement before the aggregates and wash down the rest of the material into the mixer as the last quarter of the thing. You should be able to get uniformly mixed concrete within about 100 revolutions at mixing speed, both in terms of uniformity of air content, slump, coarse aggregate content, etc. And monitor the number of revolutions that you are putting on a mixer at mixing speed and agitating speed. Sometimes there are limits on the total number of revolutions. Other production issues are to periodically look at your aggregate gradation. The big challenge here, of course, is to control the addition of water. There is some water that may be held back for addition at the job site. Make sure that is communicated to the purchaser as to the amount of water that can be added at the job site. Aggregate moisture needs to be checked periodically so that that contribution to water is known. There is, the general practice of adjusting the slump at the slump rack, and that process should be controlled so that excessive water is not added. And then any job site water addition should be recorded on the delivery ticket and signed off by the purchaser. Periodically check the yield, slump, air content of your concrete that you produce, maybe at the plant, or also do companion testing at the job site to make sure that the testing lab is doing the right job. The delivery time to discharge is an important factor. It costs about $1.50 a minute for your truck time. And so ensure that the contractor or the purchaser doesn't keep your truck too long at the job site. And this also impacts the ability to deliver concrete at the right slump and the air content. And if the delivery is too long and not anticipated, then there may be an excessive job site water addition that will adversely affect the quality of your concrete. Things vary in summer and winter, and you may have to make adjustments with seasonal changes to your concrete mixtures in terms of admixture quantities, and other adjustments to manage concrete at different temperatures. The other aspect is to track your concrete performance. These are some of the factors that you may need to look at. Try and keep the batch record and the test data together so you can see the impact of your batching on your test data. Also make sure that there is some record of the job site adjustments. Make sure that your drivers are aware of what the proper practices for testing concrete are so that they can observe what happens at the job site as to how your concrete is tested, both for fresh concrete properties, how those cylinders are made, and how those cylinders are cured before they are transported to a lab. Understand how you can evaluate your acceptance criteria and any other restrictions to delivery in terms of time or number of revolutions on the truck, and also look at the ability to do non-destructive testing in case you get into a strength problem and what happens with cores. This is some charts that producers sometimes use to track their concrete. On the left is the data. It shows when a strength result may not have met the requirements of the specification in red. On the right, you see some visual indications of your strength test records to show when you might have dipped below the red line and indicating a strength failure. So these things are useful and need to be tracked by obtaining all your test results and tracking your concrete performance. So some of the NRMCA resources, we have courses such as the technical courses, specification courses. We have a higher level durability course. We have a course that gives you an understanding of your business principles. This is referred to as the Think Like an Owner course, so that you understand your costs and establish the right processes to minimize those costs and increase your profitability. There are several publications that can be used internally for ready mix producers as well as to your customers. These are the TIPs and CIPs. The Improving Concrete Quality course, we also administer an annual quality award. We get about 50 producers who submit, and about 35 to 40 of those do get the award. This award generates benchmarking information on quality, and that benchmarking survey report is available so that you can understand the various costs associated with quality. So as you understand that, if you need a copy of that, send us a request and we can get you a copy of that. So in summary, we went through a lot of details of quality control. You may not need all of them or you may not use all of them, but these are general principles to ensure that you have the right level of quality for the market that you serve and for the customers that you are trying to retain. Please contact us if you need more information. Visit our website at this link for the resources, and we will add more resources as they are developed as it relates to quality. You can contact me, Colin Lobo, or my colleague, Kartik Ogla, for more information on quality control activities. I thank you for your attention, and I hope this presentation was of some value to you. Thank you.